Hello, everyone. My name is Yongkang. I love AWS. I love Kubernetes. I'm fully certified on AWS. Yeah, hopefully I can get the AWS good jacket. I'm the first one globally to become a Kubestronaut. I'm fully certified on Kubernetes. I'm the first Kubernetes blue jacket globally. So let's talk about a Karpenter, the just-in-time nodes for any Kubernetes cluster. Yeah, I was planning to record a video to talk about a Karpenter by myself. And then I realized that my friend Frank from AWS, he did an awesome sharing session about a Karpenter at one of our Hesuga Kubernetes user group meetup. So I decided not to reinvent anything, just leverage whatever we already recorded. Okay, I'm putting together the Karpenter introduction.
Thanks, Frank. Over to you.
Thank you, Yongkang. Thank you. Very glad to be here. My name is Frank Fan. I'm a container solution SA based in Melbourne. So my role day-to-day, talk to customers, talk to our service team, and help our customers to better use the service. But another side, I'm also part of the Kubernetes community. So today, very glad to share what I learned. And then hopefully you can get something from here. Probably start with why we have this topic, right? First, we talk about the challenge. What the challenge today we have about Kubernetes scaling. And we talk about Karpenter. It's about overview, but most importantly, probably I want to know the audience here, how many of you are familiar with Kubernetes? Hands up. Because it depends on how deep we can go into, right? Nice, awesome, a few hands, thank you. And then we can dive deep into that. And in the end, depends. If you're interested, we will say. So do a demo or not, up to you. All right, first of all, why scaling is important? If it's a small environment like this, don't bother. But today you have lots of workloads and it's not a trivial task. Can anyone here tell me why scaling is important? It's a small group, feel free, yeah? Absolutely. The application team need your service up running. I need it now, or even better, yesterday. Right? Do you have capacity in demand? More? Why scaling? Absolutely. If you have application running business critical, when you scale out, you ensure it serves the request. But when you scale in, all right, I'm scared. Is that yeah, exactly. Is high availability when you scale in, and also I don't want to get the application already completed, but no, still continue running. I still pay the bill. It's not good sign, right? Yeah, more and more you need to consider, and also for the upgrade today, lots of security patches, lots of things you need to keep update. While you update your node, do you think your application will continue up running? Are you confident to put your hand on your heart? I'm confident. I wouldn't get a call Friday night, right? It happened to me in the past when I was managing an environment. So these are all the challenges today. How are we going to resolve that? Yeah, Kubernetes community, we have solution. Anyone here familiar with cluster autoscaler? Hands up? Yeah, you have a solution, right? That solution is already there. How it works, you can say you have pod. When I say pod, it's workload running, right? But workload need to be run on the node, which is underlying compute, right? How that compute will make that available and leverage here is called CA, cluster autoscaler, and then autoscaling group, which is a concept which a group can scale out, scale in based on demand, and then talk to EC2 API. I need a resource. I need a EC2 instance to serve my need. That's typical process, right? Simple. Anything wrong with that? Nothing wrong? Wait a second. All right, so this is what happened. You can see here, I have two node group. Each node group have different instance type. This one have smaller instance node. This one have slightly bigger double size. All good, right? Here, they're all running, right? Pretty full. But now I have workload upcoming. They are pending. I need a resource. I need to run. What happened? Our scaling group will scale out to get no new nodes. And then, here we go, happy. I find a home. Any problem here? Why? Actually, you're right. It's a tricky question. The potential there's waste. For example, if I only have this node group here, if, right, it's big node. If I don't have a smaller one, right? Even I have a small cubic here, I need to provision a big node. I need to predefine the node size. But who knows what type of workload will come in? I maybe provide a huge node to serve a tiny workload. It's not best, right? So this is a auto scaling, but beyond that, also operational overhead. Probably I noticed, Jay, you show your slides. I noticed you use Spot, right? How many node groups do you have today? A lot. Right? It's not a trivial task to manage a lot node groups, right? You need to remember, this node group for Spot, this node group for this instance type. Not easy to remember. And how do you can expect your application team know that, right? There are lots of the hand holding to ensure your right application running on the right node, not trivial task to manage. Now we have answer. It's how Karpenter. By the way, today I'm working for AWS, but Karpenter is open source software. We talk about Karpenter is not just about AWS, it's software we already donated to CNCF, and it can be run on on-prem, can be run on other cloud provider as well. So today's knowledge, even you don't use it, that's fine. You just understand what's the challenges today, and perhaps you can think about how I can optimize my environment, right? How it works, this typical way, right? But we don't like the middleman. Let's get rid of them. Use one single approach, unified approach, and simplify this provisioning. Any benefits can you think of? Sorry, I didn't talk about the detail. I asked you for benefit, but just give a guess. No? All right. Let's get into the benefits. First of all, cost optimization. I just provide the right size of instance for you and better utilize your node resource. And I can scale up and scale in based on your demand. I don't leave the node continue up running. I will consolidate the compute. Secondly, diversity. I can easily provision different type of instance types and for your variety of the workload, like ML and Gen AI, which is sometimes unpredictable about demand. Last but not least, how many of you today manage Kubernetes clusters? Hands up. I'm sure you enjoy work, but is that walking in the park? Upgrade, patching all the time, you need to keep up to date. And it's not lots of heavy lifting, I would say. Let's talk about some details, right? When I talk about scaling, we need to understand what requirement customer asks for. Your application team, I want to scale based on CPU, memory, storage, network, CPU, on and on. And you, operation team, find the right instance type, right? It's like magic. How you can find the right instance type? There are so many, hundreds of instance types. And we are not stopping here. We continue on with high availability. I want to provision a different availability zone. I want to make sure you always have capacity. I want to get the lowest price. So many dimensions you need to consider, put that into consideration when you determine instance type. And on-demand and spot. Spot instance is a cost-effective way for you to leverage some additional capacity. But some caveat for spot is it could be not available for you, but I'll give you a notice for 2 minutes for you to properly shut down or properly evacuate your workload. So we'll have different strategy, right? For on-demand, always go with the lowest price, but spot, we want to have a balanced policy. We want to give you low price, but also ensure have good capacity for there to reduce likelihood of interruption. All right, let's get into some details, right? So here is a configuration will provide flexibility to choose the right compute. So here you can see the different I've already put in. This is 3 different instance type. You choose node from this family, right? Don't give my very expensive or big different instance type. And this is the size of instance. And then you can continue on to define, I want to spread across availability zones. And Jay mentioned about the graviton, right? I want graviton save my cost. So use this different architecture here. And I want to save money. I want to spot. And I prefer spot before you give me on-demand. So give you flexibility to define what you like. And I'm familiar with this concept here. Do I need to spend time here? Hands up if you're familiar with this concept about this. Probably just briefly, I wouldn't go to details, right? When you have nodes and you have your workloads, right? How are you going to ensure your right workloads always being placed in the right nodes? It's called scheduling. It's like just move this one, put in the right place, right? So these all the mechanisms already in the Kubernetes. I wouldn't go to details, but for you, information is a Karpenter integrated with them, all of them very well. So nothing new you need to learn from the scheduling perspective from Kubernetes side, but we provide more flexibility. I think there's a lot of details, but probably I will skip, given lots of the details here, but I quickly just mention here, you can say spot, you can always provision nodes. Sorry, make sure your port will be provisioned into right spot, right nodes. In this case, is spot. Lots of technical details, I'm not quite sure. Okay, this one probably is relevant. I have different teams. I have team A, I have team B. I always want to make sure this team A have that workload running a specific group of nodes, right? You can do that. You can set up your node pool, which is configuration of Karpenter, and you can set up your workload specification. You can see they're matching up, right? And then this particular node deployment will be deployed onto the right node, which has this label, right? This is something basic for how scheduling works. Optimization. So this is the fun part, right? We want to spend less, but we want to achieve more. And everyone need to have that cost in mind. So here we have policy configured. When underutilized, I want to consolidate. How exactly that works. Okay. Before we go there, you can say 4 nodes, another 2 nodes, pretty empty, right? Lots of empty, underutilized. Why don't we consolidate, get rid of them, and combine them in the existing 2 nodes, right? It's easy to understand. In this case, this 2 node is quite large and have lots of space. Why don't we consolidate? Right? Change the instance type. Make a small instance is enough. Why need big instance? So that's about scheduling, provisioning, but most importantly, Karpenter combines lots of functionality I mentioned here and make you operational work a lot easier for your upgrade, easier for your day-to-day patching, and we wouldn't go to details, but this onboarding, how you can do it, you can install that as Helm chart, but Karpenter, you need to find a place to run it because itself cannot provision or schedule workload for itself. You need to find a place. It's catch-22. So you still need auto scaling group or the node group to run Karpenter. You can also use ECAS Fargate, which is a serverless option to run your Karpenter. And we provide a comprehensive guide for you to do migration.
So I hope it is useful to you all. And I included a few videos about cost optimization. Yeah, as you can see from the screen, I got 2 videos right now. Yeah, feel free to have a watch and provide me feedbacks. And before I'm wrapping up this session, yeah, just to share with you, Kesuga is the most active Kubernetes user group. We already got 7,800 followers globally. And we also have about 10,000 members from the most active Kubernetes discussion group. If you haven't joined us, yeah, please feel free to join us. Yeah, I hope this is useful to you all. Please feel free to reach me out by any one of the links listed here. Thank you for watching. Have a good day.